Hi students, today we are going to discuss about roll crusher. The objective of the today's lecture is to find out what is the maximum feed size we can put into the crusher and what is the roll crusher. Especially we are discussing about the double roll crusher. These are two rolls which is one is in the clockwise motion, another one is in the anti-clockwise motion. It will rotate. One is rotates in the clockwise, another one is rotating in the anti-clockwise direction. If you put any feed particle here, it will be crushed. Okay. What is the maximum size of the product that can come out from this crusher is the distance between the rolls. If you more is the distance, bigger is the particle size, lesser is the distance, smaller is the particle size. And what feed particle we have to put here is not in our hand. Okay, you cannot put randomly, because what is the size of the feed particle that I can fit in this between these two rolls. Okay, if you keep bigger particle, it won't be crushed. If you keep smaller particle, it will be fall down in between the rolls. So what is the maximum feed size that I can put on this double roll crusher? That is the objective of the today's lecture. And I have drawn the schematic on the board. These are the two rolls. Okay, this is the size of the feed, this is the size of the product. Okay, R1 is the radius of the roll, the R2 is the radius of the feed, and R3 is the radius of the product. And we also have to do force balance here. The moment you keep the particle here, the particle will feel two forces. One is at the point of contact. Okay, one is normal force, another one is tangential force. These are the two forces. Okay, that rises because of the gravity or its own weight of the particle, whatever it is. There are two forces will be experienced. One is normal force, which is Fn, and the second one is the tangential force, F2. Because of these forces, one resultant force will come, because one force is acting in this direction, another force is acting in this direction, the resultant will act in another direction. Similarly, one force in this direction, one force in this direction, and the resultant force. Always resultants need not to be a horizontal line, because depending upon the size of the rolls and size of the particles, the resultant will be sometimes in the upper direction, the resultant will be sometimes in the lower direction, and sometimes in the horizontal direction. Okay, that resultant, the direction of the resultant force depending upon the size of the rolls, size of the feed, and you can see the distance between the rolls. Okay, and I have drawn, see this angle. Okay, this angle made by these two lines is called AN, and this is called, the half of this AN is called AN by 2. Okay, and because from the trigonometry, geometry and trigonometry, you will get how these the values have come up. This is A point, this is B point, this is C point. Okay, let us go back. Fn is called a normal force. Fr is the resultant force because of the normal force and the tangential force. The angle AN, it is called angle of nip. So the term the AN is called angle of the nip, because this plays an important role, because based on this angle AN, the direction of the resultant force will be dependent, whether it is acting upward or horizontal or downward, the angle of the nip will decide. Okay, and let us go. I have to do the force balance. Okay, because I told you there are two forces. Okay, one is Fn, which is normal force, and one is Ft. Based on the magnitudes and directions of this Fn and Ft, the resultant will be dependent. Okay, I have resolved the forces, because I have I resolved the forces. This is the Fn direction. If I resolve Fn into two forces, one is in upward direction, second is in horizontal direction. The horizontal is Fn into cos An by 2, the vertical is Fn into sin An by 2. Similarly, if I divide this Ft, tangential force, again I can divide the tangential force into the horizontal component and the vertical component. The horizontal component of Ft is called Ft sin the vertical Fn, because this is how the force has been resolved. Okay, see the case 1. Okay, let us see what should be the force so that the particle will be crushed. That is very important. The resultant force should be in downward direction. If the resultant force is upward direction, the particle will be lifting upward. If the resultant force is downward direction, it will get crushed. If the resultant force is horizontal, it is neither go up nor go down, it will stay at the same location. So the case 1, what happens if Fn sin an by 2, the vertical force is equal to the downward force. If the vertical force is equal to the downward force, the particle will stay at the same location, which is called, if the particle will not be pushed upward or pushed downward, it will simply, the particle will be pushed sideways, okay, because of only this horizontal force that is acting on the particle, because upward and downward forces got cancelled out. So that the angle, that is the an, the angle at which this happens is called bite, angle of bite, because neither it will go up nor down, it will simple stays, just like something is bited there, okay, that is called angle of bite. This comes in the case 1. If upward force is equal to downward force, then this happens. Let us go to the case 2. So this is the case 2. What this case 2? If Fn cos an by 2 is less than Ft sin an by 2, that means the upward force is more than the downward force. What happens if you keep the particle over there? If the resultant is in upward direction, okay, because the resultant is in upward direction, so the particle will try to lift it up, jumps over the rolls, okay, that's what because the resultant is in upward direction. Case 3, which is essential, we require, if Fn cos an by 2 is greater than Ft sin an by 2, when the downward force is higher than the upward force, what happens? The particle will be crushed and comes to the bottom. So that is what the case 3 is more essential, okay. The angle should kept in such a way that the resultant force is in downward direction, okay, the resultant force is in downward direction. Case 3 is required for particle to be crushed, which is Ft cos an by 2 is greater than Fn sin an by 2, Fn sin a, sorry, this is Fn cos an by 2, this is Ft sin n by 2, then Ft by Fn, is nothing but, okay, this Ft by Fn, if you take here, Ft by Fn is nothing but tan, sin by cos is tan an by 2. What is this Ft by Fn? And in engineering, people call the tangential force to the normal force, they call it as a specific thing, which is called friction, okay. When how much the tangential force applied over the normal force, if we calculate these two, that means it's called coefficient of friction between the rolls and the particle, okay. Mu is Ft by Fn, which is greater than tan an by 2. This is the condition to be fulfilled, okay. Ft is called the tangential force, Fn is called normal force, and tangential to the normal force is called coefficient of friction. This is the main condition, okay, for the resultant to be in downward, exactly almost downward. The mu, coefficient of friction, mu is nothing but equal to tan an by 2. The limiting condition, just like we have found the limiting condition in the ball mill, this is the limiting condition in the roll crusher. So mu should be equal to tan an by 2. For all practical purposes, people come up with the different experiments. They found that if you have to maintain 32 degree, that is the angle, if you maintain the 32 degree angle, the particle will be crushed down, because major times the resultant is in downward direction if you maintain this particular angle. So let us find the formula from the trigonometry. This is the A, C and D points. If you refer to the figure in my before, I have drawn some figure on the board. From that, geometry, A, C, D. In this A, which is called AC, the distance between A and C is R1 plus R2. The distance between A to D is R1 plus R3. What is the cos? AD by AC. R1 plus R3 by R1 plus R2. In other words, I can cos AN by 2 is nothing but D1 plus D3 by d1 plus d2. Well, I mean d1, if you know the d1, d3, d1, d2, you can able to find out what is the angle of the nip. Okay. Let us, using this formula, let us go ahead, solve one problem regarding the crushing. What is the maximum size of the feed I can put it on the roll crusher? Okay, that's the maximum size I can keep. Okay, if I keep beyond that, then the crushing will not happen. Let us go a very small example to get clarified. So let us go ahead applying the formula. What is the maximum feed size I can put on the roll crusher? What is a slake lime manufacturer, okay, a lime manufacturer uses double roll crusher, okay, to crush the limestone. Okay, they have the machine which have a roll diameter of 1.5 meters. Okay, clearance between the rolls, that means maximum product that can come, size that can come out of the roll crusher is nothing but clearance between the rolls. Okay, which is a product diameter, which is d3 is equal to 1 centimeter, which is nothing but 0.01 meter. Okay, if the angle of nip, because if the angle of nip as per the, I mean based on the experience, they have wanted to maintain 30 degree, that means an is equal to 30 degree. In such conditions, what is the maximum feed size particle I can put on the crusher? So if you put beyond that, it will not be crushed. If it is less than that, every feed particle will be get crushed. So let us apply the formula. Cos an by 2 is equal to d1 plus d3 by d1 plus d2. That implies cos 30 by 2 is equal to 1.5 plus 0.01 divided by 1.5 plus d2. d2 is the diameter of the feed particle. From this, what is the d2? d2 is nothing but 0.064 meter or 6.4 centimeter. That means in order to make a product of 1 centimeter with these conditions, maximum feed I can put on the roll crusher is 6.4 centimeters. If you keep beyond 6.4 centimeters, there is less chance that is going to get crushed, because the resultant will kick him towards the top. Okay, it will try to jump on the roll crusher, it will not be come down. This is the application of the formula, angle of the nip. Okay, always remember angle of the nip. Okay, I hope you have learned of the roll crusher. I mean, let us meet with some other video. Thank you very much.